The next panel is going to be business perspectives on climate change, and I would have to say that in a certain sense, I think this panel is really where the rubber meets the road. We've heard a lot of interesting ideas. The question in our market economy, of course, always is which ideas will be able to survive within the marketplace. And the next panel is an interesting one because it is people who are involved in setting up companies, venture capital, whose job it is to assess some of these ideas and see which ones of them can actually succeed. So to wrangle this panel, we have Steve Parry, a partner from NGen, and he's a geologist with many years in the field, set up a variety of companies, and he will introduce our panelists, and we'll just lead right into the next session. Thanks.
Well, good afternoon. I guess we're afternoon now. My name is Steve Parry. I'm a partner at NGen Partners, one of the new clean tech venture funds that are currently entering the market or have been in the market for the last few years. I'm delighted to be here for the session today. We're just getting a bit organized on logistics. Delighted to be part of a session like this. Most of the presentations we go to, or most of the events that we participate in, tend to be, okay, to move it back up, tend to be more financially driven, and to be involved in a session where a number of authors have spent a couple of days talking about the problems and the issues we have to face. It's fun to be in the position of talking a bit about some of the solutions. So we're going to try and focus on the solution side of the issue today. We titled this particular presentation, Managing Climate Change and the Financial Imperative. I'm going to try and get at some of the realities as a venture capitalist I have to face when looking at investing in companies that have potential solutions that would affect climate change down the road. We refer to as a clean tech investor. Clean tech investors are sort of a new group in the venture capital community. We're concentrating on everything from water to renewable energy sources and so forth. The way we try to do these investments, the way we try to manage our portfolio, is to be essentially a hedge better, where we will invest in both the renewable energy side and pollution abatement technologies. We'll invest in water treatment technologies and potable water solutions and so forth. By doing that, we try to take out some of the risk that's inherent in systems set up within regulatory bodies and so forth. And that's really the trick behind what we do. This is a list of some of the companies that we've invested in. Two of them you're going to hear from today, PowerSpan Corporation and Konarka. In addition, some of the other folks we've invested in, Catalytic Solutions, which provides new low-cost catalytic converters for automobiles, sole focus in the concentrator PV world, and Renaissance Lighting in the LED space. Because we'll be talking about PowerSpan and Konarka in more detail, I'll just mention a couple of the things that we're involved in, just to give you a sense of what a clean tech investor might do out there. Sole Focus is a recent investment of ours in the concentrator PV space. This is one of perhaps 40 companies that are now in the market, either raising money or spending money, developing products with the new products like triple junction photovoltaics, where you're seeing 40% efficiency in cells as a real opportunity in the marketplace. We believe that these are leading to a major shift in the cost of PV. We think this will be one of the innovations that drives PV to be competitive in the power world, along with what we'll term 3G technologies, the kinds of things that Howard Burke at Konarka will be talking about. So we're very excited by what's going on there. We also invest in things like the LED lighting space, where we see a major energy savings on the horizon. But to get this to happen, you have to see a whole series of things occur first. You have to see these products enter the marketplace, and where they seem to have found their sweet spot, where they seem to be available and saleable in the market, is in the area of architectural lighting. Once you go there, then you get to white light, which is, of course, the holy grail of the LED lighting world, where you start to see it affecting the overall energy balance in a real and meaningful way. All this is fine. As we look at our opportunities to invest, this kind of chart sort of demonstrates one of the problems that we have to face. We're going to diversify across each of those bubbles. At the boundary of each one of those bubbles, you're going to find regulatory and policy decisions being made that add risk. It makes it difficult for us to assess whether to invest in one technology or another, depending upon what a policy might be within the U.S. or international governments in terms of that sector. So that increase in risk actually is an inefficiency in the market that creates cost and means that dollars don't necessarily go where you'd like them to go. Why is that important? Well, for me, this is the most fundamentally interesting statistic out there from IEA, the number of dollars required to build out the energy infrastructure in the next 30 years. That's $16 trillion worth of investment that will either go towards clean tech solutions or will not go towards clean tech solutions. And I think it's part of the same story I've heard from several other speakers in the last couple of days. The problem for me as a financial investor is that the people who invest with us are not what we'll refer to as mission-driven. They're here to make money, and therefore I have to find ways and places where I can place their funds that have a true opportunity to make a positive rate of return. The good news is there are a lot of things that are going on in the clean tech sector that are clearly headed in that direction, and that's the positive. Now, you have to, I suppose the best thing I can say is when we're looking at governmental policy, making sure that we don't let policy interfere with that imperative becomes a critical piece of the story. I'm going to keep my remarks relatively short right now so we have time to hear from the three entrepreneurs that for me are really the key part of this particular session. We want you to hear from people who are actually offering real-time solutions today that have opportunities to change things in terms of climate. In the U.S., however, the areas where we have most concern, we were part of the first half dozen funds that started to invest in the clean tech sector about half a dozen years ago. Today, there is a real boom taking place. About 10% of total venture capital dollars are heading in this direction. That's a good thing. If you think about what venture capital achieved in things like the biotech revolution or in the internet, it's positive. We always worry that these things overrun the market, and you have situations that happen, for instance, in the fuel cell industry as Ballard Power simply got ahead of itself in terms of its perspective in the marketplace. Things like the Energy Act, where actually government policy will affect us, become critical to this whole thing, and the variances between local and state and federal mandates becomes pretty important. The good news in the U.S., solid patent rights, efficient financial markets make a lot of this possible to be pretty excited about investing here. As a fund, we do invest in projects which end up in China. In fact, I spend a lot of my time trying to get companies to take their products to China. We sell a water purification system in Beijing now that is on the market. We are trying to move other companies within our portfolio to do that at the same time. The biggest issue we run across in doing that is the issue of patent protection. We see it as a tricky thing to manage working in the international scene. The good news, however, would be, I would say this was actually offset almost entirely by what we see as the government's ability there to move quickly. We spent quite a bit of time looking at the e-bike market as sort of an example of what can happen in a market like this where a formal decision is taken with respect to two-cycle engines. That was subsequently, I'd say, improved with the decision on LPG scooters and their launch in Shanghai. So we see that as a positive and something that we would be very motivated to follow in terms of where we put our investment. Last part that I want to talk about, and this is just prognostication. What venture capital investors tend to do is look for trends, possibilities, things that may change in the future where the delta will create a financial opportunity. We look at the emissions trading world, and we look at what's happening in the Northeast states. We look at what's happening with cities. For those of you that watched Al Gore's film last night, very interesting, some of the trends that are going on. You look at the AIM marketplace, where Eco Securities has got a $300 million market cap as a trading company in emissions credits. They launched CDM projects on the international scene. These are early, small-scale signs, but they still point to the possibility that there is a democratizing of incentives for rollout of clean technologies that may be very important as we move forward. We're not sure where it's going yet, but maybe we can give you sort of an example of one prior example where there's some perhaps interesting parallels. We would also say that we believe that whether or not you have a position with respect to carbon today, you are taking a position by de facto, because being short in carbon in the future may be just as bad as not having played the market at all. Here's an example from the SOX marketplace, SO2 allowances in the United States. Very interesting thing happened here when it launched in 2001. The sort of the bar chart in the top left-hand corner just shows you the building volume of trades possible, and then in brown, the future forecast, what's going to happen as this market continues. What causes that number to drop is the lowering of standards. In other words, there become less credits to trade. Interesting thing happened in 2004, 2005, a relatively stable market at sort of the $100 to $200 range per ton suddenly launched up into the $1,200 a ton range for SOX credits. Happened very quickly. Why is this important? Well, this is what the daily trading graph looked like for price change in SO2 during that period. And it's sort of seismic in its appearance, and you can imagine that within the companies that were short when this happened, this was an extremely negative event. In other words, being short definitely had a price. Is there a direct parallel with the CO2 world? Well, we don't know yet. But if you think about last year, and I know the price of carbon has dropped since this point, but if you think about the implications of the price rising to $30 over the course of the year, just an interesting sign. Is there actually something there that will be important in the marketplace over the next decade or so? The graph on the bottom is just, again, one group of estimators' view of the high, low, and middle case for carbon price in the future. If you start thinking about a price going into the $1,000 a ton range, you start talking about trillion-dollar markets, and that's one of the things that excites us about this business. That's an extremely democratizing event. If the capability to create a tradable product ends up with pricing like that, that money will go to the most efficient location for treatment or for creation of a carbon credit, and that's a better mechanism for managing technology than trying to pick the winners between various forms of solar PV and so forth. So let me get out of the way and get the entrepreneurs up on stage. The last two parting thoughts I'd leave you with: we think the readable regulatory trends are the most important way to reduce investment risk, and we think that potentially democratized policies with respect to carbon trading may in fact have a major impact in the marketplace. Thank you. Now, as I said, let's move on to our primary speakers here today. Our first speaker will be Luan Feng with Falcon Pioneer Technology Company. Luan, do you want to come up on stage and let's get you started here.
First of all, I have to thank you for have this chance to be here, and but since the time's very short, I have to cut into the start. And let me first introduce our company, which is in China we're pretty popular. Everybody know almost in this industry about the China 5E, or independent information service company. We have this website. So we actually established in year 2001, and we're main business energy information and consulting service, coverage traditional energy sectors and alternative energy. So now it becomes the most frequently visited influential energy website in China. Sometimes, we got like between 100,000 to 300,000 page view, like every day. What we're trying to do is build an information highway for the China energy industry. So for mainly our customers, like governments, investors, developers, equipment manufacturers, or suppliers, operators. The reason we call China 5E means that's our principle, which so we serve the energy industry, and so we promote environment, efficiency, economy, and the e-business, which is pretend like information, new information technology. Our course strength is the most comprehensive energy website in China, a large pool of energy expert professional teams. And also we have multimedia marketing capabilities and a fundamental track record. So also we have a very large database in China energy news clipping and industry reports. Ever since the year 2000, we start collect whatever the things we got, from website, mediums, domestically in China, or somewhere from international resource. So our team has 10 years experience and excellent track record in energy project consulting in China. So it's basically our business lines, like energy information, marketing, promotion, energy research, and consulting. So what we provide, the service, which is actually we do for the news flashing and news weekly, since we have a lot of experienced expert working along with our editor, so we process all the information to have a better service. And also we have this 3 journals, which called the Power, Coal, and Oil and Gas, and Energy and the Environment. The most recently, we also had a team up with World Bank, for another journal come out with related to the energy efficiency. So talking about the information service, now we provide tailor-made packaged or personalized energy information package, and we do the statistic database, which is complete production and customer statistic on the major engineering products, and news clipping as well. And also we do some marketing promotion for the various clients, like we hold conference and do the public relations, and so all those service. So what I like to talk about is we established a research center since we have so many information gathering. So we had this research center established last year. We basically provide service for the project evaluations, investment analysis, project financing, and the strategy study, the technical feasibility as well. Oh, well, now, next things I would like to talk about is like there's one case study we carried through over 3 years. It's about natural gas utilization problems in China, which is actually we are we deeply involved with Beijing's natural gas utilization project. Is now we have set up joint venture company with the Beijing Gas Group to promote decentralized CCHP technology. It's like we have collect a lot of data, and we did the research. Then you can see on the graph, it's great. It's about like Beijing. Once we adopt clean energy, Beijing's the first city has fully supplied within like a 4th ring road. If you have been Beijing, probably will see fully supplied by natural gas for the middle-sized boilers and the household use. But there was problems for the power supply and the gas supply. You'll see the curves. There was the data was taken by year 2002, which you'll see the natural gas and the electricity. They have 2 different peaks. One is in the winter, the other one is in the summer. Since China, particularly in Beijing, during the summer is pretty hot, the winter is pretty cold. So, and electricity we're using mainly is for the air condition, electric air condition. So during the summer it's very high, and during the winter we use the natural gas to heat this. But the problem is because it was so rapidly changed, we go for most of our natural gas go for the boiler. So we only use probably 1 to 9 during the whole years, during like 4 or 5 months. The rest of the time will be stay almost idle. For electricity, we have similar problems. You can see it, and during the summer, it's very peak high. And so summer, the power we only need for like less than 1,000 hours. So it's a very difficult situation, and city governments try to balance it, but so far, the situation still hasn't been changed that much. So you can see the peak. So for the natural gas, so over 4 years, you can see every winter it goes up during the during the summer it drops. So that's the consumption. You can see the very big percentage used for the heating. And here, okay, China used the natural gas. I think mainly reason because try to resolve the pollution problem. And so we built this natural gas pipeline over, now it's almost like 9 years. And so the first line now ran the full capacity. The second one now already arrived at Beijing last year. So you see these 2 pipelines go through the, it seems that Beijing is the only city now had a very sufficient gas supply. And so also connect with this project, start building the LNG terminal. So hopefully this terminal will be in completion of year 2008, just for the Olympic, probably able to complete before that time. So that's the situation. And then in the beginning, nobody knows, and everything is so expensive, nobody want to use natural gas, but it's all of a sudden start rapidly grows. But I remember the year before last year, the winter, there was shortage. The government actually have to start, shut down a lot of boiler, try to save the natural gas. So the natural gas utilization in China, there were certain conditions that there was a very specialized. Probably in other countries are the same, but in China the problems are very obvious. Like it's really in the initial development stage, so only probably like less than 3 or 4% of total energy consumption. So, and also we have got enough storage. So only 2 or 3 underground storage is very costly, very expensive. And also the gas is production is very expensive because it's the cost by quality of a resource. It's like and meanwhile the market competition with coal-fired baseload power plants very severe. So with those considerations, it's actually 2 years ago, part of our research team, they had suggestion 2 or 3 years ago actually, say we should utilize the natural gas. By the way, it's like replacing the small and middle-sized coal-fired cogen plants in the city, in the cities. So we did some serious calculation because we have all the data. We calculate and we count every single unit among like 3 provinces near the coast: Shandong, Zhejiang, and Jiangsu plus Shanghai. It's altogether 700 units, small coal-fired engine running there, and also it's about like 14 gigawatt total capacity. So we will make suggestions. So we should go to renovate this smaller coal-fired plant. Particularly now that China, the older population start go for urbanization. Small towns now becomes a city. So a lot of coal-fired power plants in the middle of the city. If you utilize natural gas to renovate it, they'll be, very good in terms of clean the environment, and meanwhile was clean the air, and So another thing we made suggestions, so we go for use the DE CCHP system to build for the residential and the buildings. Because that time when the our company is the first one actually introduced the DE concept to the China that time. So we just gave a very short briefing, and we call CCHP system because I realized that here people's much more academic than had a lot of background in industry. It's a CCHP is actually combine heat and the cooling and the power together, which is you can see from this the paragraph. Actually, as we learned from a lot of scientists strongly support the CCHP because for natural gas, the sufficient burning temperature is about 1,300 centigrade. But if we use for the boiler, so you only need the 500 centigrade, for the sufficient burning. It's really a lot of waste. So that's why if you use CCHP, you can increase the efficiency to up to 80 to 90%. Whatever the saving is really very substantial. So actually, it's sort of like general power and the residual heat used for the boiler to generate the heat, hot water, whatever, for the building use. So that's you can see the diagram. So it's just some drawing. Okay, here. So actually, we also at that time proposed a DE clean energy center for the Olympic. That's some, we adopt the idea. In America, I think California has a university that's in that, which is called the Energy Park, which is a fully used CCHP and renewable technology, energy technology. So you just like loop the whole district. So actually, we use this to design this energy center for the Olympic. We actually got through the mayor, supported. There was 6 very distinguished scientists signed a letter, but we didn't actually get proof because I'll say it later. That's our drawing for that center. So actually the concept, I'll explain why we didn't get proof. Because, it's for the, okay, it's what we learned from a Danish power system. So you can see 20 years from this big central power plant, they convert to decentralized power. The whole GDP increased, but the energy consumption did not increase over 20 years. So then we got the idea, we tried to demonstrate, talk to the government, try to get their support of proposal. But the problem is like, the CIECC, which is China International Engineering Consulting Company, which is owned directly by NDRC. So they have done some research. So talking about the use of natural gas, it's like 70% they say should be used for the power generation in order to balance the whole supply system of natural gas. So with that concept, so NDRC decided to build a large energy power plants along the pipeline, natural gas pipeline. And the large gas turbine, then the second thing they want to do is they want to make the large gas turbine made in China. So they start import around 23 sets of 350 megawatt large gas turbine, then plus contract with technology transfer. So then within this plan, there was 4 of them supposed to be built in Beijing. There was one has been built, the other one will be built for the Olympic, which is actually in the downtown area. So the power plant is going to be 670 megawatt, right into between the 4th and the 3rd ring road. So I don't know, but that has been put in the construction now. The sum of those power plant has been built. Serious investment on the subway line, since we want to make that domesticize the whole equipment, so it's already in place. So that's all the projects, power turbines, the list. You can see the 23 site, 5 come from GE, the other one 5 from Mitsubishi. So that's the second one project. The first one is what I'm talking about, 23. The other second one started from this year, will be another more than 20 will be in place. So now the problems after, there was a couple of, I think 4 or 5 has been built. Then the problem is that we run out of natural gas. We don't have enough natural gas supply. And so it comes back to the problems of why we need the natural gas, since China is very rich in coal. Of course, it's clean, it's probably, it reduces sulfur. So that's, that's one problem. Then it's where's the market, because the electricity is so cheap there. So it's almost impossible for them to sell the electricity. Now that's a very serious problem. So because of this, then there was short on gas, so nobody should pay attention to DE anymore because there's no natural gas anymore. Then the state have to, try to build the LNG terminals, now approved 14 LNG terminals along the coast. Then we don't know where we can buy the LNG. So if we use CCHP rather than large baseload power plant, that's, will be like a lot of money. It's about like, we count about like $5 billion spend it. So if we spend that much money for the CCHP or DE or renewable energy, that'll be another story. So talking about the carbon dioxide, if we use CCHP, there will be 30% extra efficiency. That's how much we can save, equals tons of carbon dioxide reduction. So that's, our problem. So actually, let's see here. So that's why we come up with some conclusion, that we try to, explain to the decision makers, like we should adopt modern technology which is best suitable for the China. And we should not just, simply follow some other developed countries' step. We should really consider, the China situation. Now, the only suggestion so is that our research center will try to promote something which we think probably is, right. It's the most important is to correct energy strategy, development strategy in China. And the government policy and the investment should support, which is, the policy, which is actually we think is sound. 2 things is energy saving, which is improve the efficiency. We can probably promote the technology. We think it's like CCHP, DE, and IGCC. We know there's a lot of people working on the IGCC according to, it still takes us time, but as I know, there was some entrepreneur has already put these things in function. It's economically, it's feasible. But we were also support the other things that we're looking for the new resource, like renewable and nuclear fusions. So it should have a lot of tensions, and the government policy support, also the money, the investment should be come to support this policy. Okay, that's my time is okay. Thank you very much.
Our next speaker will be Frank Alex from PowerSpan. I've known Frank for quite a few years now. Frank's a nuclear engineer, originally from the General Dynamics in the Portsmouth Naval Yard. Put his own money into a company called PowerSpan a number of years ago, and then decided, having made it a profitable company, to start back at square one and then build it to something bigger to take on the much larger problem of pollution in the coal-fired power plant business. So, Frank Alex.
Thank you very much, Steve, and thank you for the opportunity I'm greatly honored to be here with so many distinguished speakers. I appreciate the effort made by the number of students I see in the audience and members of the faculty and community, as well as the China delegation. I think it speaks to the importance of the topic, and once again, it's an honor to be here. David Hawkins and Peter Schwartz mentioned that coal is undeniably, at least in our near-term future. I have the distinction of having begun with nuclear power, which for some of you I'm sure is in one part of the dark side, and now I'm trying to clean up coal, so I'm trying to make a transition. Our company is devoted to the notion that you can have clean coal, and I'm going to talk a little bit about that. Most of what we've seen today has reinforced that coal is very important, particularly for the United States and China. If you look at in the U.S., typically 50 to 53% of our electricity is produced from coal. And on either coast, the west or east, you don't see a lot of coal-fired plants, but certainly in the Midwest and the South, you know coal is a very important source of power. If you look at some of the statistics on this slide for worldwide coal usage, China certainly jumps out. India, some very big and growing countries depend quite heavily on coal. If you look at the share of the world's coal, certainly the U.S. is, they say, the Saudi Arabia of coal. We have more coal than anyone in the world, and there are some very strong forces in the U.S. that intend to use it. And fortunately or unfortunately, depending on which side of the debate you're on, that's a good or bad thing. It helps keep our electricity costs low, and that's important for the consumers, for our industry. But it has a byproduct of pollution, not the least of which is CO2, which is a real problem. China, of course, has a lot of coal as well. In terms of coal consumption today and in 2025, and these are based on Energy Information Administration projections, China, which today is the largest coal user, will grow even more significantly over the next 20 years. Double the coal use in the U.S. is projected. So clearly, if you're going to get serious about coal and cleaning up coal and addressing climate, the two countries that you most need to think about are the U.S. and China, as has been previously mentioned. My company is called PowerSpan, and we are developing clean energy technology systems for coal-fired power plants. We initially started, as Steve mentioned, out with something that cleaned up particulate pollution better than anyone else. We had a profitable company, but we saw a much bigger problem and decided that we were going to go after the whole enchilada, as they say. We've raised a lot of venture capital, about, I think we're up to $60 to $70 million now, which is one of those good and bad things as well. Having the capital to do what we needed to do is great. Having a bunch of venture capitalists on your board can be trying at times. But we are at a point where we have a technology that's commercially available today that will reduce sulfur oxides, nitrogen oxides, particulate emissions, and mercury, as well as any technology you can buy in a single system and meet all federal and state standards in the U.S. today, and at a price point that's below anything you can buy today. We're also developing a CO2 capture technology with the Department of Energy that will be readily integrated with this process. Our biggest achievement to date is this, what we call our ECO, which is our Technology Commercial Demonstration Unit. That picture to the, I guess, the right is our first commercial foray into this marketplace. It was about a $25 million investment, which is a big risk. So for the investors who got behind us based on a very small unit and decided to build the unit that you see there, it's a little over 100 feet high. It was a big risk, but fortunately for us and for them, it's worked well. We've definitely demonstrated the process on a commercial scale with commercial operating procedures. We've been through some very, very rugged performance tests where we demonstrated 99+% reliability. We demonstrated that we qualified as a best available control technology. The U.S. EPA specifies best available control technology typically for new plants or in a new source review situation where you've upgraded the plant and you have to put the best technology. Well, we went through a series of tests that were sanctioned by the EPA, so we qualify now as best available control technology for sulfur dioxide, nitrogen oxides, and particulates. EPRI, which is the big research consortium in the U.S., funded a study by an independent engineering firm that concluded our technology, based on a failure analysis from the bottom up, would be as reliable as conventional technology or better. And finally, we've got our next order, which is about a $130 million unit for First Energy's Bayshore plant, a 215 megawatt unit. So we do have our first commercial order and looking for more for sure. In terms of what's the potential for clean coal, because that's what I think the audience cares about here, and certainly our colleagues from China care about, we believe that you can make a coal plant as clean as gas. Now, that's a pretty big statement, and a lot of people in this room probably won't believe that. But we are prepared to guarantee emission levels of 1 to 2 parts per million on the outlet of a commercial coal-fired plant today. Now, unfortunately for us, our customers don't really want to buy that. If you look at the market today, they have standards for emissions that are considered the best. And it's been delivered by technology that's been available in Europe, Japan, the U.S. for about 20 years. And stepping up those standards to reduce emissions drastically from where they are today establishes a new best available control technology, and by definition then, when you build a new plant, you have to deploy it. So there's a huge disincentive in the United States on any coal-fired plant to step out from convention. So even though we can demonstrate to our customers and would offer a guarantee to these very, very low levels, they're very quick to point out to us, no, 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 we don't want that, because that would establish a new standard. And again, you know, I'm not blaming the power companies. The rules in the United States and the fact that they report to shareholders and they report to consumers who want the lowest cost electricity supplies drive that decision. That's just a rational decision based on the rules and the economics and the shareholders. China, on the other hand, at least to my knowledge, does not have that type of situation. They have more of a tax per ton of pollutant emitted. So there is a built-in incentive in China where these regulations are being applied and enforced to limit emissions to as low a level as possible. So just that one structure in China may mean that this technology is a much better fit, and that gives the Chinese market the chance to take some leadership, as we've said, seen many of the speakers mention. Another aspect of coal that I think gets probably a bad rap for a good reason can be solved, and that is waste. Only about 30% of coal combustion byproducts are used today. Some ash is put in cement, concrete blocks, road aggregate. Some of the flue gas desulfurization byproduct is put into wallboard. However, if you look at technologies such as ours, pretty much 100% of the byproduct can be recycled. The only thing that we have that whether you recycle or dispose of as hazardous waste is kind of up in the air is mercury. A big coal plant emits about 100 pounds of mercury a year. And whether that's an opportunity to recycle or you just put a small package of that in a hazardous waste disposal facility is a question for us. But by and large, all the sulfur products that we produce are fertilizer, ammonium sulfate. There's no new liquid waste from our pollution control equipment. So the idea that the back end of a coal-fired power plant has to be dirty is also something that technology has an answer to. And finally, in terms of CO2 capture, the technology we're working on with DOE says, or at least demonstrates at the lab and bench scale today, that we can capture at least 90% of the CO2. We think that's a low number. We think the number is actually going to get much higher before we're done. But the costs, and this is the important piece, the costs projected by this DOE study are less than $15 a ton, which includes sequestration. Now, if you look at conventional wisdom, it says that CO2 capture from coal-fired power plants is about a $50 a ton nut. And that's why we have to go to IGCC. Our research indicates that we can drop that cost by about 2/3. Now, in terms of CO2 capture processes, just a quick primer. You have to absorb the CO2 from the flue gas. You have to take that CO2 in solution and release it. And then you have to recycle that solution to be cost effective. You don't want to consume anything with CO2 in most scenarios because there's so much CO2, if you consume a reagent, for example, it becomes a very expensive process. The research project we're doing with the Department of Energy uses ammonia. It's the same reagent we use to capture sulfur dioxides and NOx. So it's something that we have a lot of experience with. It's available on site. It's part of our multi-pollutant process. Ammonia, compared to what you could buy in the U.S. today, which typically is an amine process, monoethanol amine is the brand if you're familiar with it. Ammonia has much higher CO2 loading capacity, so you can capture much more per pass. Much less energy for regeneration. That's where most of our cost savings come from. And the reagent itself is much lower cost. And as I mentioned earlier, when we do our testing and get greater than 90% CO2 capture, we're doing that under commercial conditions, the kind of conditions that you can afford to deploy at a power plant with known equipment. One of the interesting aspects of this conference, and particularly this research area, is the Department of Energy, before signing an agreement with PowerSpan, signed an agreement with the People's Republic of China, and specifically the Ministry of Science and Technology, to cooperate on development of CO2 capture using ammonia. Right now, there's very similar R&D going on, not only in the Department of Energy labs, but in PowerSpan labs and China labs on the same process. So today we are, in fact, collaborating on this process. China, I think, has a leg up on us here. They have been practicing carbon capture with ammonia for over 40 years. It was invented in the late 80s, and it was used as a way to get ammonia in a solid form, produce ammonium bicarbonate as a pellet so they could put solid nitrogen on the fields. These processes they use with coal gasification today are capable of capturing 98 to 99% of the CO2. So clearly, in terms of CO2 capture from coal combustion, we're showing greater than 90%. In China, they're showing 98, 99%. The capture process is clearly demonstrated. The regeneration process is where the development and the R&D is going on for us and DOE both. In terms of producing a fertilizer byproduct, which is something that PowerSpan does, clearly it's another great fit for China because of the population compared to the arable land in China. They really have a need to maximize the productive use of the arable land that they have, and the way to get the maximum agricultural yield is with the proper use of fertilizer. And today they are the largest fertilizer producer. Is IGCC the only clean coal answer? Again, if you're familiar with the coal space, integrated gasification combined cycle technology is quite promising. It is clean, it can be quite efficient, and it does produce a fairly concentrated stream of CO2 at pressure, which on the surface appears it would be cheaper to capture and sequester. However, there's been a couple studies, and both done by Department of Energy, one with EPRI participation and one with Parsons, an engineering firm, and both show a rough equivalence of costs. That is, if you look at the cost of electricity from IGCC with CO2 capture, the DOE study says about $54 per megawatt hour, or 5.4 cents per kilowatt hour. Now, there are studies, Amory studies, mentioned a price up in the 8, 9, 10 cents per kilowatt hour. So these numbers vary quite a bit depending on your assumptions. But interestingly enough, another study with very similar assumptions done for the Department of Energy says if you have a new supercritical pulverized coal plant, which is kind of the state-of-the-art conventional plant you can buy today, the cost of electricity with ammonia-based CO2 capture and sequestration is the same price. And in this case, it includes sequestration. The incremental cost of electricity is only about 20%, or about a penny a kilowatt hour. So think about that. If the United States consumer industry is asked to spend an added penny a kilowatt hour to take the CO2 from coal-fired combustion and put it in a safe place geologically, is that too much to pay? I think the obvious answer to that question for most everyone in this audience would be, of course it's not. That the risks far outweigh those kind of costs. And our point really is that there is new technology that can make even the existing coal-fired plants. A lot of people look at those as stranded assets that have to be shut down, but that's a very hard thing to do. History has shown that a fully depreciated asset that takes $1 billion to replace is a really hard thing to shut down. What we would say instead is, let's invest a few $100 million and make it clean, not replace it with a $1 billion plant. So what we're trying to say is, we think we have an answer for the existing plants, and we think we have an answer that could be applied to new plants of conventional technology that could answer this question. Where we are, we're at bench scale in the lab, designing a pilot unit. We expect to be at pilot scale, which is about a 1 megawatt, 20-ton-a-day unit sometime next year. First Energy, who has been one of our big investors and sponsor, they're an Akron, Ohio-based utility. They burn a lot of coal. They are sponsoring this, have already invested in it. The next step for us is to also conduct CO2 sequestration at that site. Some of you may know that the Department of Energy has regional sequestration partnerships, and the Midwest region has quite a few coal-fired power plant owners, coal companies. Obviously, the Midwest is the center of coal. And that partnership has selected our project as a site to not only capture the CO2, but sequester it. And then finally, we think the opportunity for commercial scale is really enhanced oil recovery. And I got a couple quick slides on that. I'll be done. Department of Energy has asked Advanced Resources International to figure out what the opportunity is for enhanced oil recovery in the U.S. The most popular approach of enhanced oil recovery once you've injected steam and water and some of the easy things is injecting CO2, which has been mentioned. The opportunity here is that about 2/3 of the large fields in the U.S., 1,000 out of about 1,500, are very favorable for this type of enhanced oil recovery, and the amount of technically recoverable oil is about 88 billion barrels. If you look at that number, that's about 12 years of current U.S. oil consumption. It depends on a couple things, but the biggest one, if you look to the bar chart to the right, is low-cost CO2. There is no real source of low-cost CO2 widely available in the U.S. There are a few domes where we pipe CO2 down in West Texas, Permian Basin, but there are a lot of coal-fired power plants. And if we could develop our technology, get it to the commercial phase, get $15 a ton CO2 out there, there'd be a lot of oil companies line up to buy it. Finally, what's the market for this? Under the modest scenario, where only half of this recoverable oil is recovered, you've got about 10 trillion tons of CO2 purchased and sequestered. That's about 6 years of annual oil consumption and about 4 years of current U.S. CO2 emissions from power generation. So our feeling is this is a great opportunity for us because the power companies aren't buying our technology. But if we can get to the commercial phase, we think the oil companies will. Finally, summary. We think technology can provide an answer, but as Steve mentioned, you need clear regulations because it's hard for companies like us to raise the amount of money we need without knowing there's a profit in sight. Capital's available, again, Steve mentioned, but venture capital barriers and costs are pretty high, and they're not patient. So knowing that you can make some money from CO2 climate-based technologies is important, and today that's very uncertain. I think the China-U.S. collaboration should help. You know, certainly China has an opportunity to show leadership here, which I think is very, very significant. And we're committed to starting our own business in China this year, PowerSpan China, where we think both conventional multi-pollutant options plus commercializing the CO2 technology is a great opportunity in China. And then finally, in terms of where we're going to get our money, we think it's oil companies. We think as much as some of you don't want to see more oil produced, in the short term, if we can get CO2 in the ground producing oil, the CO2 trade-off is about even, believe it or not. The amount of CO2 it takes to produce a barrel of oil is about how much you get out of a car. So at least it's a trade-off that gets us to market, gets the technology commercialized, and then it's available for the coal-fired plants. That's all I got. Thank you.
Thanks, Frank. Our third speaker and final speaker for the day will be Howard Burke with Konarka. Howard is that unique human that is a multiple company entrepreneur, has launched, I think you're up to 13 companies at the moment, if I remember your bio correctly. Remarkable track record, one of the well-known entrepreneurs in the renewable energy space, and a member as the director of the American Council on Renewable Energy. Howard Burke.
This is not the first time that I have followed Frank, who is an excellent speaker, a company that I compliment his leadership, and PowerSpan is certainly a company that I believe in the future will be quite successful. Talking about the future, which I think is the theme of this conference, to peek into the future and see what you see, and often you don't like everything you see, so the opportunity is to change the future. I have great respect for Vice President Gore, who I've met several times, who has visited some of my prior companies. I've been involved with a variety of new technologies, and I've listened to the world, including the Bill Gates and Andy Groves of Intel and others, say it'll never work. But I challenge you that magnetic resonance imaging does work. I challenge you that minimally invasive surgery does work. And I challenge you that voice over IP and video conferencing over IP networks, real-time communications over IP networks work. And those are some of the startups that I was involved with and brought these technologies to the world. So speed the clock forward. I'm 51, 30 years doing this. I think for me, before I depart from this planet, no time soon, I hope, I'd like to leave my mark in terms of changing the future, which my Jewish grandmother, may she rest in peace in heaven, said, Herschel, leave the world a better place than when you came to this world. So before I leave this world, I want to make it a better place for my 13-year-old son and 2-year-old daughter, and all of you and your children, your children's children. So as Vice President Gore brilliantly and in a very entertaining way depicted in his movie last evening, which will be generally released later in the week, we look into the future, and it's not a pretty sight. So let me say, as a director of the American Council of Renewable Energy in Washington, that there isn't a renewable I don't like, but I love solar. And what others have heard me say, and the ladies in the audience will understand when I say I'm in love with a certain type of solar. So that's what I want to talk about, and that is Canarca Technologies and what new technology we hope to bring to the world. So let me tell you why I'm in love with organic solar. You heard about coal and liquefied natural gas. Man has burned animal peat. We have burned wood. After we stopped burning wood, we started burning coal. The people in London choked to death, so we discovered this black thing bubbling up from the ground, and we started burning crude oil. And then the EPA said, thou shalt not do that, so we fell in love with with natural gas. And then the president said, we got to do something about importation, so let's switch to liquefied natural gas. But what is the common theme here? The common theme is that organic materials have really been at the basis of man's harnessing energy. But I believe Albert Einstein and then thereafter Thomas Edison showed us the way. And Thomas Edison said man should look to the sun for its future, for civilization's future source of energy. And in deference to the first speaker, I don't believe Thomas Edison was referring to nuclear fusion because it hadn't even been invented yet. So I think Einstein deserved to win his Nobel Prize for explaining the photovoltaic effect. And I believe Thomas Edison was correct. And I'm honored to stand here at this conference and say Al Gore is correct. And I believe the future, as in the past, is based on organic generation of energy. But instead of breaking those hydrocarbon bonds, why don't we figure out how to harvest organic chemistry to make energy and convert energy, as opposed to pollute our atmosphere and create a very bleak future. So I'm an optimist, so I think we can do something about the future. And what Canarca is focused on is renewable energy. Not only the imbalance between supply and demand, which obviously is driving commodity prices worldwide, but keep in mind that there's something very unique about solar. So it's a diverse audience. I want to kind of keep this at a high level. So what makes solar different than other renewables? Why do I love solar and I like other renewables? Well, solar is both a distributed energy source as well as a renewable energy source. And for one who has also built communications and computing networks, increasing the reliability of the distribution of energy is the role of distributed power. That's what makes our communications and computing networks so reliable. That's what makes the U.S. grid only 85% quality of service. As a network, it's an embarrassment. My wife is Swiss. She says, now I'm living in the developing world of America. Why? I live in the wealthiest town in New Hampshire, and we lose power last year about 35 times. And the wealthiest community in the state of New Hampshire. Why? Because the wires are strung and the trees fall and the ice and the snow. You won't see a power line, at least a low-voltage power line, above ground in Switzerland. And in fact, Russia has a higher quality of service for its electric grid than America. So China is developing an electric grid. The United States is trying to figure out how to deal with an antiquated one. And Europe has electric grids that are extremely reliable, like communication networks. So there is an imbalance between supply and demand but there is also a challenge on how we transmit and distribute energy over an electric grid. And then lastly, if you haven't figured out, I'll ask you another question here. What is the most expensive source of power on the planet? I like audience participation. What's the most expensive source of power on this planet? Is it a nuclear reactor? What's that? It's a AA battery. You pay a lot. We as consumers pay an enormous amount of money for the benefit of portability for just not too many watts. So it doesn't necessarily, although it does, affect climate change and carbon dioxide, but keep in mind that we don't only have an imbalance between supply and demand in electricity, we have an imbalance between supply and demand on what a battery can furnish to the industrialized world. For anyone who carries these around or anything like this, and all the manufacturers of these, they are faced with a dire imbalance between supply and demand from batteries. So CNARC is as well focused on power as well as electricity. Just a few words about our history. I'm proud to say that not only are we a spin-out of UMass, we are a spin-out of the University of California, specifically the Santa Barbara campus. Founded in '01, we've raised over $60 million of venture capital. I think that's a good thing. I've raised, I think, about $300 million in my career. We have 3 locations, U.S. and Europe. We're headquartered in the Boston area. Our headquarters in Europe are in Nuremberg, Germany, the Energy Center for Germany. We also have labs in Austria and Switzerland. Now 50 employees, 39 of those PhD-level scientists. Our patent portfolio is nearly 300 patents and filings worldwide. And I'm proud to say in 2 of the cases, because one of my degrees is in architecture, we're housed in rehabilitated mill buildings. The one on the left, our headquarters, when built, was the largest operating textile mill in the world, based upon the mighty Merrimack River that almost drowned us not too long ago. So by 4 feet, we missed being drowned by the Merrimack River, but that river powered the canals. Renewable energy powered that mill. Our partnerships, as I mentioned, we're led by venture capital, most recently globally. 3i led our round. The leading venture funds in Silicon Valley, Route 128, as well Europe. Our corporate partners include some of the names you can well recognize. Siemens, Chevron, Kurtz is one of the leading printing companies of the world, which I'll explain why that's important to us. Eastman Chemical, DuPont, Merck, EDF, the largest utility in the world. Our research partnerships, and we've received over $8 million of grant support from the Department of Defense, specifically Air Force, Army, and Navy, DARPA, but also the EU. The largest grants in this field of science have been awarded to CNARCA. Partnered with NREL, the National Renewable Energy Lab in the U.S., and its counterpart ECN in Europe. No time, but we're, I think, now 19 universities in U.S. and Europe that we're affiliated and partner in our research. This is a repeat, but worth repeating, particularly honored to be here and sort of facing the future together, united between U.S. and China. 2005, this is current world energy usage. By 2025, expected to double, essentially doubling the U.S.'s demand. Why? Because 15% of growth in annual demand is represented by 1/3 China's demand on the world market. So what does renewables look like today? Well, there's the pie. It's a 15 terawatt pie, and of it, renewables are about 2%. Hydro is still, it's a renewable, and still larger than other renewables such as solar and wind. But solar is a fraction of a percent. So if we're going to change the future, I don't know how we're going to do it if solar is only 0.1% or less. So what did Thomas Edison really have in mind here? If this is the future, and Al Gore painted what the future might look like 20 or 30 years from now, how are we going to get there? Well, Solar is the fastest growing electronic product on this planet. It grows faster than iPods, it's growing faster than displays and computers. 35–40% compounded annual growth rate. Impressive. It's driving the solar stock market. It's driving solar industry. We're going from $8 billion to projected $30 billion in global sales. It's impressive. It's astounding. It's wonderful. But I'm a little colorblind. Do you see that little tiny bit of yellow on the top of that bar graph? That's solar's contribution to the world's energy, as predicted by the Department of Energy of the United States, based upon 35% annual growth. So how are we going to get there? There has to be a disruption. Something has to change about solar. As much as I love solar, it's not going to solve the problem the way we're going. Something has to change. So I'm all about market disruptions. So what's the disruption here? Well, go back to what I started to say. We're focused on energy, and we're a biotech company. We're an organic chemistry company focused on energy, printing electronics, printing photovoltaics. We're changing the way you manufacture PV. Has anybody here handled photographic film? Everyone. It's near obsolete. You probably all have digital cameras. So what did photography look like 100 plus years ago? Well, it was thick silver halide crystals deposited on thick, heavy glass in a metal frame, very heavy, very expensive, and not affordable. And in fact, our great-grandparents and grandparents probably only had one photograph of their wedding. So how in 100 years do we get from photography in a plate, which looks like a current photovoltaic, it looks like a solar module today, right? How do we get from there to now it costs about 3 cents a strip for Kodak to put the photographic film into a package that costs more than the film? And how is it that the 2.5 billion people on this planet who have no electricity have access to photography? What changed is the manufacturing process, a roll-to-roll, high volume, high surface area, continuous process to make film on polyester, not a batch process putting deposition on glass. And it's that disruption, it's the printing of electronics, which is a bigger theme than just Canarca and photovoltaics. So Canarca is at the intersection of these three big themes. So how do we do it? We do it a layer at a time. These are nano-engineered materials put down in micron thickness layers using advanced coating and printing technology, not semiconductor processes. It's hard to believe that the roofs of our 1 million homes in California and all around the world are going to come out of semiconductor processing plants that make little chips. I mean, it's just mind-boggling to think that that is the manufacturing solution. So what we believe is make PV like you've made photographic film, like other high-volume, low-cost manufacturing is done, only with very innovative, novel materials. So we build it up layer by layer. It's layer by layer. It's encapsulated. It's sandwiched between printed electrodes. And what you see there are photographs of actual prototype materials that Canarca has made off of our pilot line in Lowell, Massachusetts, as well as our pilot printing facility in Nuremberg, Germany. And on the bottom is an actual, it looks too pretty, but it's a photograph of our prototype modules for the Air Force for PV, renewable energy tenting materials. So the product potentially is a fraction of the cost of conventional PV, about 1/10, an order of magnitude better power to weight, flexible like photographic film. And for the first time, whoever said that cars were only black and whoever said PV had to be black. So I have samples I can show you. Canarca is printing PV in different colors with printed patterns. So we can simulate roofing tiles. We can put a corporate logo on a sign and it's making energy. So for the first time, PV need not be black and need not look like a black surface on a roof that wants to be red in Switzerland and adobe in Spain and wants to have the appearance of a tile or some aesthetic pattern on your home. If you go into Home Depot or Lowe's, I'm out here, it's Lowe's, you'll see that you can buy conventional roofing material in 8 or 10 different colors. Why do you buy PV only black? And we have very unique properties of our materials in terms of harvesting lower light. And I want to come back to this theme about environmental acceptability of these materials. The process is a scalable, low-cost, low or less energy-intensive roll-to-roll process, which for those who are keeping track of the economics is about 1/10 the capital cost. So to build an amorphous silicon plant like Unisolar, where our president visited in Michigan, that's about $100 million. To build a Canarca plant with the same capacity is about $8 million. No clean room, no vapor deposition, no vacuum deposition. So let's talk a little bit about the effect of these materials. So today, 99% of PV is based on silicon. Environmentally a very acceptable material, but to purify it and to grow it is very energy intensive and very costly, and thus PV is not mainstream, can't be mainstream until we dramatically lower its cost. In the 70s, at NREL and other places, at universities, in an effort to dramatically change the cost, thin film materials were invented. Some of you, as I look out, are too young to remember the OPEC oil embargo and all of that, but you know, we're just living deja vu of what has happened in the past, but for different reasons. And so these inventions created these new thin film technologies that are 20, 30 years old. Some VCs, particularly in the Silicon Valley, have re-fallen in love with them, but they're environmentally quite risky. Why do I say that? Some of these materials are based on cadmium, selenium, arsenic doping. So I submit to you that the way to solve one problem is not to exchange it for another. We learned the lesson painfully from lead in house paint. We put asbestos in building insulation. Several companies, big companies, were bankrupted over it. And now tell me the solution to climate change and the world's energy imbalance is to put lead, selenium, arsenic and gallium, and cadmium on the rooftops of California homes. I love solar, but we have to understand that not every renewable, although it is a trade for carbon dioxide, has a zero environmental footprint or impact. So our belief is, happens to be in the same column on the periodic chart, if you didn't notice, what's right above silicon? Carbon. There's plenty of it, and there's plenty of silicon, but processing carbon, much lower temperatures, very different manufacturing processes. This can be done out of solution in a printing process. So in summary, my favorite PV is organics. No toxic chemicals, no known carcinogens. Silicon, there's a limited supply in high purity. It's very expensive, and that's the feedstock that drives 95–99% of the PV industry today. Same for amorphous silicon, of course. And there are a variety of CIGS and CIS companies in California here, and they are using toxic materials. And for those countries that still allow, there is in fact a U.S. and a German manufacturer that's making PV from cadmium and telluride. Our process is much more energy efficient. There's no harmful waste, no or zero emissions. For crystalline silicon, expensive semiconductor processing, clean rooms, energy intensive, the same with amorphous silicon, including the handling of very toxic gases. I was talking to the former VP of Environmental Health and Safety for British Petroleum. The facility British Petroleum worries most about is where they do vapor deposition of amorphous silicon in PV solar. Very, very toxic gases are handled. And of course, energy intensive. The same is true with CIGS. Hydrogen selenide gas does not have a very appealing history in mankind, but that's what many CIS and CIGS facilities handle, hydrogen selenide gas chambers to make PV material. Of course, also energy intensive. Cadmium is outlawed in Japan, outlawed soon in China in electronics, outlawed in the EU. It's soon to be outlawed in California, but yet people are using it in PV materials. So in summary, there is a great challenge, but the challenge needs to be met with not something that's sort of evolutionary. There needs to be a disruptive change if we want to see renewable energy, particularly solar, have a more meaningful impact on the energy and therefore carbon dioxide generation for the future. And that disruption better happen sometime soon. So CNARC is at the intersection of alternative energy, as I said, organic chemistry and advanced printing electronics. We're only 4 years old, and PV silicon is 50 years old. And I'm proud to say, although I can't share the details, we had a great breakthrough at CNARC today. And so when people ask, what efficiencies are we up to? I used to say, well, we're closer to 10% than we are 0%. But CNARC, and I have the IV curves off to NREL with these devices, CNARC is now at 10%, targeting higher than 10% conversion efficiencies from organic materials. And we've done that in 4 or 5 years, and Mother Nature in 100 million years has an energy conversion efficiency called photosynthesis at 2% efficiency. So in 5 years, we're at 10% and going. 100 million years, Mother Nature's at 2%. A scalable, efficient roll-to-roll coating and printing process, a paradigm shift from silicon, expensive feedstock, to organics, which can be scaled up in enormous availability through the chemical materials industries, not only, of course, in the U.S. and Europe, but as well in the PAC Rim. These are environmentally acceptable materials. If they aren't, as CEO, I will not allow our chemists to work with them. Our proven business model, we don't make your product, we make your product make electricity. It's the old BASF model. We have corporate partnerships amongst the leading companies in U.S. and Europe, and soon announced in Asia. As I mentioned, we're funded by leading VCs in the U.S. East and West Coast, as well as in Europe, and to date about $70 million of funding support, a 200-man-year experienced management team, a world-class scientific team. My chief scientist, my co-founder, is the Nobel laureate in chemistry in the year 2000 from UC System, Santa Barbara, for inventing organic conductive polymers, plastics that convert light to electricity and electricity to light. You know them as the bright blue light on your Nokia phone and the bright brake lights, but when you put light in, indoor or outdoor, they generate electricity. Worthy of a Nobel Prize, worthy of the University of California. That's the market disruption. That's the technology disruption that we CNARC believe will make solar not a fraction of a percent, but a significant part of future energy generation, renewable energy, and therefore maybe we can save the world together. Thank you very much.
All right, this will take questions from the floor.
Question is for Mr. Kirk. I'm wondering, can you say again the conversion efficiency of the product and where's your current market of your product, and your vision of your future market?
I believe the question was, what's your current efficiency and what are your current and target markets?
As I mentioned, and I can't say how we've achieved it, but the results will be certified. Our current cell efficiencies now are at or close to 10% and soon to be higher. These are cell efficiencies, so when you put cells together, which we do monolithically, the module efficiencies are lower. But what I didn't have time to explain is, and I tried to highlight this by the sensitivity of these materials to both indoor and outdoor light, These materials behave very, very differently than crystals. Silicon, whether it's in monocrystalline form or polycrystalline, which is most of PV today, or amorphous silicon, which is the thin film deposition of silicon, these are all crystals. And their behavior is very, very different than organic compounds. And what we're finding is at extremely low light, so early in the morning and late at night, and indoors, these materials have very, very high conversion efficiencies. So I'd like to say, and I've said this to our new Assistant Secretary of Energy for Renewable and Energy and Efficiency, who's a friend of mine, that there is a bit of a big lie in the solar industry. And that's the conversion efficiency that manufacturers report to you. So when they say that a panel is 15% efficient, what they're telling you is a laboratory result at 25 degrees Celsius at full sun, with the sun perpendicular or the light source perpendicular to the module. So if the Earth doesn't spin, if you have a flat roof and the sun stays up over your roof and there's never a cloud in the sky and it never rains and it never snows, then you have and at 25 degrees Celsius, which is not how hot your roof gets in a black module, but you have a 12 or 15 or 18% conversion. Well, I challenge that isn't the real world. And someday when we have Energy Star rating, which I fully support, Energy Star rating for solar modules, and real world testing is done, you will find that these materials don't perform at those kind of conversion efficiencies. So our conversion efficiencies, although they are lower, we actually generate more electricity over a 24-hour day through the 4 seasons and through the year, and we're going to be publishing that data, than materials that have much higher efficiencies. You know, it would be the equivalent of going to buy a car and it says it's 42 miles per gallon. And then you read the fine print and it says, in a hurricane with a 60-mile-an-hour wind behind the car. How meaningful is that miles per gallon if that's the way it was reported? You know, you buy an Energy Star washing machine. If it tells you what the annual consumption of electricity is going to be, and in the fine print it says, family of none, 2 washes per year, how meaningful is that data to the consumer? So I have to tell you, the solar industry reports a conversion efficiency, which is a laboratory result, which is not meaningful to what you will actually see in the real world. Why? Because they have nothing else to sell. It's all black, it's all heavy, it's all glass. Pretty much the only thing they can report to you is a laboratory result and what does it cost.
Question over here.
What's the longevity here over the last next couple of years? And number 2, there's a lot of interest in paintable materials. Are you offering that same?
The second part, interesting. Paintable.
Repeat the question so
First part was about longevity or the stability of these materials, and the second part about the suggestion that some of these materials may be paintable. Some have even said sprayable. In terms of longevity, I will tell you that I think that's where Konarka's real challenge is, that organic materials are photostable. We don't believe that our first product will be a 30, 40-year warranted product. Our first go-to-market, that was an earlier question, our first go-to-market is to address portable power markets. It's to address applications where the color, the lightweightness, the flexibility. Our organic materials are quite stable if put on glass. Plastic is not as good a barrier as glass. And so we see our chemistry both being coated in a patterned way on glass, as well as printed and coated in pattern on flexible substrates. Our partners will be and are the leading printing and coating companies on both glass as well as flexible substrates. And so our first products will be in the range of a 5 to 8 year life product, and then working with the technology and pacifying it and stabilizing it, you know, we believe we can achieve a 15-plus year product. But let me just tell you my belief about solar. If you're putting a solar power plant in a desert, and there isn't going to be a lot of cloudy days, and you have a large surface area, and you can have a tracking system to track the sun, and you can cool it because it wants to be more efficient as it's cooled, then you should do that with the highest conversion efficiency silicon the world can produce. But if you're putting PV up on a rooftop of your home or an industrial building or a warehouse, and you're in Chicago or Boston or New York or London, then why would you buy a material that's ideally suited for the equator when there are materials that will perform much better in your weather conditions? Yeah? Your second part, your question about sprayable, paintable, there's a lot of hype around this technology. We print, we coat, but the idea that you're going to be able to take an aerosol can and spray the side of your house and stick 2 wires at the other ends and get a current is dangerous hype around this technology. It's really dangerous. We have to collect the electrons and induce them out through electrodes. We use printed electrodes, but there's a defined pattern. The electrons don't want to come out. They have to be coaxed out with electrodes at 2 different voltages. And so it's a little bit cartoonish. It's a bit immature. I even know some VC-backed companies that would have you believe that this is possible. It's just it's sort of a Hollywood way to explain. But the fact of the matter is that printing of electronics down to even 10-micron resolution can be done now with RFIDs. The resolution to print a PV is not as precise. So advanced printers of the world like Kurtz in Germany and Topan in Japan, others can do this and are doing this with us. But that doesn't mean you're going to be able to just, buy a PV in a can and paint it on or spray it onto the side of your house. I just think that that's too naive.
Maybe we'll go to the back corner here.
Question for Frank from Counterstat. Obviously, coal is really critical, particularly in China. In talking to other people in the clean coal industry, there seems to be a tremendous optimism that you shared in terms of the ability to capture, but to sequester at the sort of volumes that are going to be generated globally. There seems to be a little bit more concern about it within the industry. And I'm just wondering what your thoughts are about that, both with your own technology and just with the industry more broadly, to really make this a reality.
There's been these regional partnerships in the United States, and that's the only area I have any knowledge on. So what the situation in China is, unfortunately, I can't speak to. But in the United States, Department of Energy, beginning about 3 years ago, funded regional partnerships. And one of the first things they did was take an inventory of likely geological sites for sequestration. And most of these sites are below some impermeable cap, like our gas and oil. And in many cases, they're porous. They not only allow space, but in a lot of cases, they chemically bond the CO2, to go from lime to limestone, something like that, where you tie it up with a chemical change. So you're quite secure that it's not going to be released. And the inventory in the United States suggests that we have more than enough geological inventory to sequester all the CO2 from all the coal in the United States. Now, that's a big statement, and I'm not making it from my own knowledge. I'm telling you what reports coming out of these partnerships that are funded by Department of Energy says. Now, the assumptions, not unlike oil assumptions, as someone mentioned earlier, the easy oil is the first 15% or so you get out of the reservoir, and then there are things you can do, but by the time you get about 20 or 30% of the oil out, it gets really hard. And I don't know if anyone's done a qualitative assessment of that statement. I suspect that some of the reservoirs will be quite accessible and easy, and that under a carbon sequestration scenario that we would see, there'll be pipelines, not unlike natural gas, ammonia, other large pipelines, oil pipelines in the U.S., to move CO2 to the best spots. But whether or not that much sequestration capability is economically viable, and whether you can prove that it stays sequestered, there are a number of standards being developed, and now they're starting to
go through the second phase of the partnership, which is just put the CO2 in the ground and really prove that it stays there for the long term, which is a whole nother question. So I think we're at the early stages. The first cut is there's capacity geologically, whether or not it's economically affordable and you can actually prove the CO2 you put there stays there, I think are the next steps in that process. And it's a 5 to 10 year process probably.
And fair to say that we even got 10% of that, of the volume opportunity to happen on the existing coal fleet. That's still a huge number in terms of reduction of carbon. So it doesn't have to be a ubiquitous solution to be very, very complementary to other things that are going on. We're allowed time for one more question.
Oh, I just want to add one quick comment that I've heard from other panels around the world. The CTO of EDF made a very good point, which is distributed energy can be anything you want. It doesn't have to be renewable. Why don't we put tiny little nuclear reactors in every town and village, and that would be distributed energy, and it wouldn't be renewable. And so everybody laughed, and they understood the difference. So go back to coal. What I think is, and I've discussed this with others who would be more expert than I, you know, the carbon dioxide that comes from the transportation use of fossil fuels, where you're talking about hundreds of millions of points of generation, if one could change the fuel source, for example, with gasifying coal in China and having a different fuel source, then the point the CTO of EDF was making is if you have problems, it's better to deal with one smokestack than 10 million smokestacks. And so I think that the opportunity here is to look at ways in which coal can be used to substitute other sources while concentrating the points of emission so that technologies can be focused on fewer points of emission than trying to find even lower cost technologies to deal with hundreds of millions of points of emission. And that was the point the CTO of EDF made, which I'd like to share with you.
I think we've probably used up our time at this point, so maybe we'll just wrap up the session there and say thank you very much.